Hi everyone, this video is meant to introduce you to the idea of environments within the compute cluster and basically talk a little bit about what an environment actually is and how we manage our environment. So as you can see by my prompt here, and because I'm running the hostname command right now, you can see that I'm logged into Tortuga and I am just a normal user. So let me clear that. And really quickly, I just want to introduce the idea of an environment and environment variables and talk about what that really means. So there's a command that we can run, env, or env, and essentially what it does when we run it is print out a whole bunch of variables and their values. So we can see a sort of trend here. If we look at the shell variable, for example, we can see that the word shell is in all capital letters, there's an equal sign, and then this is the actual value of that variable. So if I were to echo the shell variable, we'll see that it says bin bash, which is the same thing that env printed out for us. So what does this mean? Well, I'm going to clear my terminal again here. Environment variables are essentially a means for configuring things or interacting with our environment or modifying our environment sort of on the fly. So the one that we're going to talk about specifically is actually called path. And what path does is tells our shell or our current session where it can go to look for binaries or executable scripts or programs. And essentially, if something doesn't exist in that path variable, even if it might exist on the system outside of somewhere that's in your path, it's not going to work. So let me just show you what I'm talking about because it's going to make more sense. So I already told you there's a variable, it's called path. All of our environment variables are capital letters. So when I echo the path variable, what you see printed out is basically a string of paths on the system separated by colons. So if I wanted to run a script that was located in a directory that was not one of these listed in my path, it basically wouldn't work. So when might that happen? Well, let's say I just logged into Tortuga. I'm sitting here at a fresh terminal, and I want to stage a job running Bowtie. The problem is I don't exactly know what parameters or what command line options I need to run with Bowtie. So it seems pretty simple, right? Let's just type Bowtie help. Well, all of a sudden I get this error that Bowtie cannot be found. So what do? Well, almost all the software on the cluster is installed in opt. So if we go to opt and list the contents, we can see there's a Bowtie directory. So let's change into that directory, list the contents again. Okay, there's two different versions of Bowtie. There's Bowtie 1 and Bowtie 2. Both major versions of actually different programs. So we're interested in Bowtie 1. Let's go inside this directory now, list the contents, and all of a sudden, here's our Bowtie binary or executable. So now that I'm in this directory, if I type // which represents this current directory that I'm in, and then type Bowtie followed by help, well, it prints the help output. This is what I wanted. So that's great, right? Except let's suppose that I don't want to go into the directory every time I want to run Bowtie. So how do I do it? Well, there's a couple options. So if I go back to my home directory by typing cd and I clear my terminal again, one thing I can do is type the whole path to Bowtie. And we just found out where that was. And now if I type, using the full path, if I pass the help flag, I get the help output. But that's pretty long to type every time. So what else can I do? Well, I can add that location to my path. So the way that we set an environment variable by hand is by using not really a command, but a shell built in called export, and then the name of our variable. And now what we'd like to do is add Bowtie to our path, or specifically the directory that had our Bowtie 1 binary that we're interested in. So if I ran this right now, I would be able to run Bowtie. But because I'd be stripping out all the other components of my path, I wouldn't be able to run any other commands, basically. So what's the solution? Well, if I type a colon and then put in my path variable again, this basically says, export the variable called path, and then we want to set the value equal to opt bowtie 1.1.2, and then a colon, which is our separator, and then we put the variable name. And what this says is after what we're adding or prepending to our path, put the existing path in place. So if I run this command and I now echo my path variable, what you can see is that prepended at the beginning is our bowtie directory. So now, if I type which bowtie, it finds the binary, and I can just type bowtie followed by the help flag and get the full output. So that's great, right? But let's say I log out of Tortuga and log back in. Okay, so run hostname, I'm back on Tortuga, I clear my terminal, and I type bowtie help. Well, bowtie's not there again. So what's going on? Well, if I echo my path, what we see is that the change we made to the path variable is not persistent when we log out and log back in. Is this a problem? Well, no, this is actually how the shell is designed, and there's good reason for this. But in our case, maybe it's a little bit of a pain. So how do we simplify the process of adding bowtie to our path? Well, on Tortuga and Pando, we have this really cool feature, or program really, called lmod. And what lmod does is helps us manage our environment in a much easier way. So if I clear my terminal and type module avail, what I get is a nice printout of all of the different module files that lmod knows about on Tortuga. And if we look at it, we can see that there's actually 2 versions of bowtie, including our 1.1.2 that we just manually added to our path. So what does this mean? Well, if I type module load and then the name of the module with the version, what just happened when I ran that command is lmod actually echoed my path for me. So if I echo my path variable now, what you can see is that bowtie is in my path. And now if I type which bowtie or bowtie help, they work. So that's great. That's a lot easier. And we also have a nice printout of all the modules that are available in the system. What you can see here is that for certain programs, if there's a D next to it, that means it's a default module. So if I just typed module load bowtie without a version, it would default to loading 2.2.9, and that's because it's the most recent one. And so by default, lmod will always choose the most recent one as a default. The other thing that we can see is that right now, the L next to bowtie 1.1.2 indicates that it's loaded. So 2 things. One, what if I'm done using bowtie 1 and I want to use bowtie 2? Well, I can use module unload, and then I can type the name again. And now, when I echo my path, we can see that it actually modified it back to the original state. Now I can load bowtie 2. And now, when I do a module avail, we can see that bowtie 2.2.9 is loaded. If I wanted to unload every module I had loaded, you can load as many modules at one time as you want, but just keep in mind that loading several versions of the same program might cause some interesting issues. I can type module purge, and now when I do module avail, you see the L next to bowtie 2 right here is gone. So if I clear my terminal, another interesting thing I can do is type module spider, and this actually crawls through a whole bunch of files. So on a system with a whole lot of modules, it might take a minute to generate this output. But I actually get a nice listing of all the module files available with a description. So if I wasn't sure what BAM tools was, which is the first entry here, I could run module spider and look for BAM tools, and here I can read, oh, it's a C++ API and command line toolkit for working with BAM data. That's great. The other thing I can do, I'm going to load 2 modules right now. So if I load module, load BAM tools, and then if I also load, let's say, Python 352. Rather than typing module avail to see what I have loaded, because this output could get pretty lengthy, I can actually type module list, and this shows me all of my modules that are loaded. Again, if I do a module purge, it unloads all of my modules. And now if I do a module list, it just tells me no modules loaded. So even after making all those changes, if I echo my path variable, as you can see, it's exactly as it was when I logged in. And that's because through loading and unloading modules using lmod, my path was changed dynamically, sort of on the fly, and I didn't have to do any of it manually. So why is that important? Well, for one thing, it saves us time typing all the export path equals and then typing in a path to, various pieces of software, whatever it may be. But the other thing is it allows us to basically standardize inside of our job submission scripts how we're sourcing something. So there's no chance for me, I shouldn't say there's no chance, but there's a lesser chance of me making a typo when I'm typing module load Python 352 compared to typing the export command right above it. The other thing that's nice about it is if I, as a systems administrator, make a change to the Python 352 module, let's say I move the location. Well, I would just update lmod to tell it about the new location, but you could keep your module load Python 352 in your submission script, and you wouldn't have to worry about changing the path to reflect where I moved it, so long as I, as the systems administrator, update lmod's basically recollection of where that is. So that's pretty powerful. That really, really, really simplifies managing your environment. And it's not just our path variable that actually gets sourced here for certain Python programs. So if I do a module avail again, I can see, let's say I want to load NumPy for Python 352. So if I type module load and then put this in, I also have something called a Python path now, which didn't even exist before, but lmod made it for me. And now I can see that it's pointing to the site packages directory of NumPy. So the other thing that I really want to show you, and then we'll wrap this up because it's probably getting a little bit long for you. So right now, if I do a module list, I have Python 352 and NumPy 111.0 underneath Python 352. So I'm going to purge all my modules, clear my terminal, and now if I type my module load command again for NumPy, there's actually a module dependency set. Because NumPy relies on Python 352, if I just load NumPy, when I type module list, I can see that lmod actually intelligently already loaded Python 352 for me. So this is a really fantastic way to manage your environment. Anything you could type basically on the Tortuga login node, like these module load commands and all that, you could also put in a job submission script. So if you have to load 2 or 3 modules to get things working on the login node, and you want to replicate that environment in your job, you basically will take the same module load commands and put them at the top of your job submission script, or really underneath all of the SBatch directives and before you actually run any commands, and you're going to end up with the same environment across the login node and any of the compute nodes when you run a job.